An ideal gas of constant mass is heated in a container of constant volume. What is the reason for the increase in pressure of the gas? Let's look on all the options that we do here and see what is true and what is not true and why it's not true. So, the average number of molecules per unit volume increases. Well, that is not the case since it says a gas of constant mass. If we have a constant mass, the number of molecules per unit volume does not increase. So that is not the case. If the number of molecules per unit volume would increase, then it's true that the pressure would increase also. But not in this case. The average force per impact, per collision with the walls of the container at the container wall increases. Well, this is true. If a gas is heated, then the molecules are moving faster in the gas. You can see it like this. The average kinetic energy of a gas depends of constants, Stefan Boltzmann's constants, 3/2, and only the temperature. So if you increase the temperature, the kinetic energy will increase. And if the temperature increases, and you know already that kinetic energy is the same thing as mv squared divided by 2. So if you do increase the temperature, the speed of the molecules increase. And if the speed of something increase, when it collide, there will be a greater impact, a greater force on what it collides with. You know that from your daily experience. If a car collides with something, then there will be an impact at the collision. If the car has a greater speed, the impact will be greater. Therefore, B is true. So this is correct. Well, let's keep on looking on C and D, because on your next exam, there could be almost the same question, a small, slight difference only, and then one of the other options could be the correct. So let's learn from that. Molecules collide with each other more frequently. Well, actually, if the gas is heated, that is true. The molecules in the gas would collide more frequently, but it doesn't affect the pressure. If they would say molecules collide with the walls of the container more frequently, the container wall, then that could be the case. That would be the case. But just collide with each other, with other molecules, doesn't increase the pressure. You are measuring the pressure at the wall of the container. Molecules occupy a greater fractional volume of the container. Well, it says the container at constant volume. So a greater fractional volume, it's also the same amount of molecules since we have a constant mass. So constant mass and a constant volume, then there will be the same fractional volume that the molecules occupied. So D is not true. The correct answer is B.